Let's continue this topic, Gauss-Jordan elimination with the 2x2 matrix. Consider the following system of linear equations. Solve the system by completing the steps below to produce a reduced row echelon form. R1, R2 denote the first and second rows respectively. The arrow notation means the expression of the matrix on the left becomes the expression matrix on the right once the row operations are performed. So it asks us to enter the augmented matrix. This is so you make sure you know how to set up the problems. So the augmented matrix is where we take the coefficients and we plug them in. So this is 4, 12, and negative 24 in the first row, and then negative 8, negative 28, and 36 in the second row. So that's the first step to these. So once we have our augmented matrix, then we need to fill in the information that's going to result in each step. So step 1 says what times row 1, and then we're going to replace that with row 1 is going to give us a 1 in this first row, first column spot. I'm going to take 1/4 times row 1 and replace row 1. So 1/4 times 4 was 1. 1/4 times 12 is 3. And 1/4 times negative 24 is negative 6. So that's row 1 being replaced, but I haven't done anything with row 2, so this is still negative 8, negative 28, and positive 36. Step 2 is to take something times row 1 and add row 2 to replace with row 2 so that we get a 0 below the 1. How do I get 0 or eliminate that x? I take 8 times row 1 and add row 2. So 8 times row 1 is 8. And then 8 times 3 is 24. And then 8 times negative 6 is negative 48. And then I'm going to add the negative 8, negative 28, and 36. So in the second row, I end up getting 0, and then negative 4, and then negative 12. And my first row stays 1, 3, and negative 6. I haven't changed it. Now the next one says, hope you can see this on the bottom, 1 blank blank 0 1 blank. How do I get a 1 here? I take negative 1/4 times row 2 and replace row 2. So negative 4 times 0 is 0. Negative 1/4 times negative 4 is a positive 1. Negative 1/4 times a negative 12 is a positive 3. And then at this step I haven't changed my first row. Now for step 4, how do I go from 1, 1, 3, negative 6, 0, 1, 3 to 1, 0, blank, 0, 1, blank? I'm going to take something times row 2 and add row 1 to replace that with row 1. Look here. What do I need to do to get a 0 in this column? I'm going to take negative 3 times row 2, which is 0, negative 3, negative 9, and add row 1, which is 1, 3, negative 6, to get, in row 1, I'll get 0 plus 1 is 1, negative 3 plus 3 is 0, negative 9 minus 16 is negative 15. And in the bottom row, I still have 0, 1, and 3. So x equals negative 15 and y equals 3. So there's another example with more of a fill-in-the-blank type puzzle of Gauss-Jordan elimination.